My name is Steve Culman. I am the soil fertility specialist here at Ohio State. I am here this morning to talk about a couple things, but I will start by talking about what's out there, available soil health testing, and what kind of tests that you as a producer might be interested in getting done on your soils. This is a really good. That exchange right there was a really good prelude to this talk, because you'll see that there's a lot of questions and very little answers at this point. So I want to start by, let's define what the heck it is we're talking about. Soil health means a lot of different things to a lot of different people, right? NRCS officially defines it as the continuing capacity of the soil to function as a vital ecosystem, et cetera, et cetera. So it's a very thinking of the soil in a framework that's very holistic, of course, thinking of it as a breathing biological organism, which it is. And it's this matrix where you've got biology, you've got chemistry, and then you've got the mineral surface all interacting, right? I think. Okay. So, soil health is multivariate by nature. We're not going to ever get around this fact that, we understand that soils are made up of physical, biological, and chemical constituents, and of course those all interact. But to think that we're ever going to be able to reduce this down into a single index or a single number is just, it's not going to happen, because when we're talking about a more holistic view, we need to think and understand that it's a very complex dynamic system. And that sometimes in some soils, physical structure is going to be your primary constraint to production, and in some soils it's going to be a chemical constraint as a primary constraint, et cetera, et cetera. So we need to just recognize and kind of steep in the complexity of this, and that I know that there's a great desire to simplify the message and keep things simple, but sometimes we're just not really able to do that. Okay, so we already had some healthy exchange here. Can we all agree about what a healthy soil consists of? So there are some things that I think that universally we would say this is what makes up a healthy soil. Sufficient nutrients, good tilth, rooting depth, good drainage. We don't want a soil that's chock full of pathogens or weeds, of course. And we want something that's going to be resilient and biologically active, right? So the problem is that, so does anyone disagree with this list? First of all, maybe we can start there. I'm sure there's things missing. This is not a complete list, but the problem is that when we start to think about, these are all concepts up here. How do we actually measure that? What's the indicator? What's the test to measure sufficient nutrients? What's the test to measure good tilth? This is where the rubber hits the road, and all these details kind of spill out and make the world a messy place. And I think the soil scientist in me can't ever skip over this slide, because I think it's very important when we think about soil health and the entire concept of soil health. We need to understand that soils are soils, right? That what you have on your farm is kind of what you get, right? So there's some hands in a game of poker that you can do something with, and there's some hands that you can't do anything with. And the reality is that no matter what the management, you're never going to take a Hoytville clay and make it into a mollisol that you find in Iowa, right? There's just physical limitations in terms of what we can actually do with our soil. So we talk about this in terms of inherent properties, things like texture, things like the slope, the drainage class, etc., how deep your topsoil is. And then there's these dynamic properties, which we're really really focus on in the concept of soil health. These are things, these dynamic properties are things that we know management can influence and can change. And so that's where we focus our efforts. We're not trying to take a sandy soil and make it into a silt loam, but we're trying to take a sandy soil and build organic matter in that capacity. And it might only get up to 2% organic matter, maybe not to 6%. But that's what we have to deal with in terms of, the soil type that we're given. So, okay. So, like I said, think about that list. What does good soil consist of? There are many things out there. Soil science has been around for a long time. We measure things. That's what scientists do. We can think about a lot of different indicators. We can classify them into chemical indicators, physical or biological. And, these are kind of well-established methods, and this is definitely not a complete list, but there's lots of different tests out there, okay? So, but the problem is that when we think about soil health testing, we have a pretty strict criteria in terms of what we want our indicators to be, okay? So an indicator, I'm using that word just the same as a measurement or a test, right? It's all the same. But we're kind of demanding when it comes to what a good soil health indicator would be, right? And so it needs to be sensitive to management, but we don't want it an indicator that you go out and sneeze on your field and then the value flies through the roof, right? We want this test or indicator to reflect some type of function. Of course, we want it to be reliable. And then the last two especially are things that we're particularly focused on in terms of the expense and can we get this incorporated and adopted into a commercial soil testing lab, right? Because I'd argue that soil scientists in a research setting have been doing soil health testing for decades. We measure, we'll sample soil, we'll measure physical, chemical, and biological properties on a soil. We do this in research studies all the time. But the reality is that those tests, it's labor-intensive, time-intensive, it's expensive, right? And so it's fine to have soil health tests that are out there now when they cost $100, $150, even $50 a pop. But if we really are serious about trying to get a lot of producers to use this as a management tool or to understand, to consider not just the chemistry but the biology and the physical structure, it's just a matter of economics. We need to drive down those costs, right? And that's a reality of putting it into a commercial testing lab and then scaling that up and let economies of scale help drive down costs, right? So that's something that we're really focused on, trying to identify the indicators that are very, very simple and quick. And it's a tall order because we can think back to this list. Well, many of these things just aren't cheap to measure. So we need to figure out how to do it faster, how to do it cheaper, right? So that way we can actually have a serious conversation. If you're going to go out and grid sample, maybe once every 5 years or once every 10 years, you're going to actually not just have pH and base cations measured, but you're actually going to have some of these biological and physical parameters measured as well, okay? And be able to afford that and not have it be a very big bill coming to your door. Okay, so I also want to talk about soil carbon for just a second. And we think a lot about soil carbon and soil science because it's very, very, very important. When we think about carbon, we think about organic matter. These things are really one and the same. 50% of organic matter is carbon, roughly 50%. And so it's very, very important property. We know this. This is nothing new that we've known that organic matter is very, very important. It is the glue, the mediator between the physical, the biological, and the chemical nature of that mineral matrix in soil. So it has lots of roles in terms of the structure, in terms of the biology, the food for the microbes, and it really is kind of the currency that energy and nutrients are cycled. And as we move that's a very true statement in a natural system. In agriculture, we're typically adding fertility to help substitute some of the mineralization, right? To help subsidize that because we have huge crop demands. But in a natural system, if we think about forest or whatever, carbon is king. What's happening with the carbon is driving that entire productivity of that system. So soil carbon and the importance of soil carbon really can't be overstated. Okay. Likely, if you're interested in soil health testing, you've probably done some of the, a quick Google search will find you some of these things. Vinayak just showed this very similar slide in terms of what's actually out there. Like you're a farmer, you want to submit some samples, what can you actually do? So I'm just going to walk through a few of these. And, maybe you're interested in a lot of the details, maybe you're not. But just kind of the point of this is just to give you a sense of the variety that's out there, right? So maybe variety is the spice of life, but in terms of a standardized soil test index or framework, we really aren't there yet. So the first one we've got is the NRCS Soil Quality Test Kit. This was one, developed in the 90s when soil quality was more of the in vogue word instead of soil health. This is mostly a field-based test. There's a number of indicators here: physical, biological, and chemical. More of a teaching and field demonstration test than actual getting precise numbers back. So it's just something to be aware of, but we really don't recommend it in the context of trying to, we think you can get a lot more precise information by sending it out into a lab, okay? Okay, so then we go to Cornell Framework, and this is a manual that, in my opinion, the web address, if you just Googled Cornell Soil Health, they have a free download manual, and they've done a fantastic job in terms of making this farmer friendly and writing to non-scientific audience in terms of understanding what they're doing. And in my opinion, in terms of kind of the soil health, all the people that are commercially offering soil health tests, they do the best job in terms of being transparent and helping the producer understand what these numbers actually mean. And certainly they were the first to offer this framework, so I think they do a very good job with it. All of their measurements are lab-based, except for they do some penetrometer readings, which measure surface and subsurface compaction, okay? Has anyone ever submitted to, I guess there's really not a whole lot of people that answered the question if you've actually submitted, but anyone ever submitted to Cornell? A few folks, okay. So they originally just had a single series, but now they've actually broken it down into 3 different tiers. There's like a $50, a $95, and then a $150 test. So however many indicators you want, but this is basically their bare bones, their basic test. And so they're measuring physical structure with aggregate stability. And unfortunately, we don't have time to get into all these measurements and what they all mean, but again, the manual is a very nice resource for that. And so then there's the surface and subsurface compaction, which is what I just talked about before. The biological measurements are respiration, the CO2 burst, which is that synonymous with that Solvita method, and then organic matter from total organic matter from what you would find on the standard commercial test. pH, base cations, and micronutrients. That's part of their. So they basically said, if we think about what is unique in terms of this, you submit your soil for a standard soil test, you're typically going to get everything in that chemical box, and then organic matter would be, maybe micronutrients, maybe not, but you're typically going to get total organic matter. So really, the tests here are that respiration measurement and aggregate stability in terms of what they think adds a different element to the standard. Okay, so with everything, here's what they do. They basically take your value, whatever, from these given tests, and they relate it. And so sometimes, in the case of organic matter, more is better, right? So as in I don't know if as you see this, less organic matter is bad, red, and as you get more organic matter, it's good, green. Sometimes things like pathogen load, more is bad, so you go into the red, and then sometimes in case of pH, there's an optimal curve where you don't want very low pH or very high pH. So they score these things, and then they put this on a basically a scorecard, okay? They color code it, so here we've got our physical, or biological, or our chemical, and our different tests, and then they score it with a number and then a color just to give you an idea of what you need to pay attention to. And so this is not an uncommon phenomenon here, right? If we notice, sorry folks over here, if we notice this is the chemical, and we can see all the chemistry, right? It's good to go. You have green, green, green. And this is, from my perspective, it's not uncommon to find this. And it's a direct result of the fact that we have very good infrastructure and testing, and it's standardized and calibrated to understand what pH is and what a good extractable potassium and phosphorus level is. But what we don't have good testing for are these physical and biological indicators. And so as a manager, these might be things that you're not really made aware of and might be neglected, right? And so this is kind of the entire point of thinking about soil health testing, because if we're not measuring things, how are you expected to manage something if we're not measuring and having some kind of indicator for that? Okay, so Brookside, locally in Ohio, Brookside is the lab that does probably most of from my understanding, the majority of soil health testing. Their tests involve this Solvita CO2 burst, which is a respiration test, an extractable carbon and nitrogen, and then a total carbon and nitrogen. And so again, we had the comment having a complete picture, so we get a total of the CNN and then the kind of that extractable fraction, okay? So every lab, let me just go back to this, okay? So this is the Cornell Framework. You got a rating, and they all score it down, and here's your overall soil quality score, okay? For folks over here, it's this number right here, 44. You probably can't even read that in the back. I'm here to tell you today that this Soil and Health Index score is an absolutely worthless number. Cornell did not want to do it, and they just people kept asking, what's my final score? What's the total score? And so they got beat over the head enough when they finally said, the hell with it, you guys want a final overall score, we'll give you one. But again, this isn't the point, right? The point isn't to know if you've got a 44 and your neighbor's got a 46. The point is that we need to think about what are the things that are your primary production constraints. Do I need to focus on the physical management and improving tilth and structure? Do I need to focus on increasing the biological components? So this is, I'll just say from my perspective, I don't think that we shouldn't really be paying a lot of attention to these numbers, and I'll show you why in just a little second. I'll have a little bit more about that. So, all right, so here's the Brookside test. And then Woods End, this is a lab out of Maine. This is really Will Britton, and who has kind of marketed and developed the Solvita test. So they have been around for some time, and I've worked with Rick Haney to develop and kind of offer this. So again, there's a physical, chemical, and biological with Solvita and this Haney extractable nutrient. So here's what Woods End offer. Are these the same things as we found in the Cornell tests? There's ag stability, measured a different way actually, pretty different measurement. There's some biology, there's that respiration, organic matter, those were in Cornell, but all this stuff is different. And then pH, and then nutrients measured not with, say, what Cornell does, which is a modified malic extraction. This is a different extractant, a newly developed H3A extractant that's part of the Haney test. Okay, so again, different methods, certainly not standardized between labs. So we saw the Cornell indicator in terms of tallying all the things that were on that test. Here's what the Woods End soil health score tallies. So it combines all these things and gives you a readout. And all these values are weighted, right? So you see this weight factor. Respiration, they give it a 1. Amino N, they give a 2. So I'm not really sure, where that came from or who developed that. But there's a whole lot of fudging and wiggle room with this. So I think that the point is that understanding what your test value for respiration is important, but trying to figure out what your total soil health score is a pretty futile exercise, okay? So the last lab I'll talk about is Ward Lab. This is based in Nebraska, and they do quite a bit of testing as well. I assume that, I don't know, has anyone used Ward Lab before? Okay, just a couple. So they do a nice job, but again, here's what they offer. No physical, only biological and chemical. And we can kind of compare. So there's some overlap, but certainly not the same. And my goodness, this thing, wonderful. Here's kind of to underscore my point. We took the same soil, organically managed Hoytville clay. We sent it to these 3 labs, okay? And they came back with different values, and they all gave us a soil health indicator score. Well, Cornell told us our soils were 56 out of 100. Woods End, 31 out of 50. So, we multiply that by 2. We get 62. And then Ward gave us a 17 out of 50. So really it's 76, 62, and 34. So what do we do with that, right? That's not very helpful. But what is helpful is knowing the values of any given test that they're giving us, and that's what we should be focusing on in terms of, as a producer, right? So, again, there's a lot of questions, very few answers. As a producer, I can understand frustration. I've experienced a lot of folks that have invested in terms of soil health testing, and they find that maybe their values that they're getting back from year to year aren't consistent. And there's a reality for that. It's because, as an industry, the methods have not been standardized across labs. And so this is a real problem. This is something that we might take for granted, the fact that it's a buyer's market in terms of soil testing out there. And for kind of the standard suite of tests, loss on ignition, organic matter, base cations, et cetera, pH, there's lots and lots of work and standardization that has happened. And this is kind of what the entire infrastructure is built on. So we need to take that same model and apply it to soil health, but we're just really in the early phases of this, and it's going to take time, right? These labs might give different recommendations in terms of how to fix the problem, but this is, of course, very valuable information as a grower to think about how you might actually address some of the constraints or some of the problem areas in any given test, right? So I think that this is very valuable to help you think about your management, how you might change that. All right. I would suggest trying to identify a better clicker for the duration of this session. So I don't know what my take-home points are, but if I had any, there are a number of different things out there. The point of this isn't to say soil health testing is like it's all hogwash, why would we even waste our money on that? The point is do you understand it's kind of a complex world and we're still sorting through a lot of the details. Ohio State used to have a public lab, and in the 90s that went away because that was deemed anti-competitive in terms of the private labs in the state. And there's a kind of this real issue in terms of understanding those dynamics of what we're doing, our role as a university in terms of providing and developing tests and information versus offering, standard tests for the commercial public. So if you think about well, why isn't Ohio offering a kind of a standard commercial test for our farmers? There's some nuances about that we need to have many more serious conversations about. But there is interest. I think Rafiq might talk a little bit about that later on. Many more questions than answers. But the final point I guess I'll leave you with is that when we think about soil health testing, and I've seen what comes back in some of these results, and I have serious issues about some of this. Sending your soils off to, say, Maine or Texas or some other place that has soils and climates very, very different than what we have here. And they give you a management recommendation, apply this many pounds N, or your soil is going to mineralize this many pounds N. I will tell you that is like a pipe dream in terms of being accurate, and it's not. That work has not been done here, right? So we need, as in all things agronomy and agriculture, we need locally based calibrations and recommendations, and we're working on that sort of thing. But rather than thinking about soil health testing as something that's going to generate an actionable item, an actionable management decision for you as a grower, I think it's more valuable to think about, I'm going to plant a flag in the sand or a flag in the ground, right? This is my value here. And then moving forward, what's happening to this? What's happening to my respiration values? What's happening to my aggregate stability? So this is the value that soil health tests that the testing has right now for you, like the immediate value in my mind for you as a grower, what that might be. So thinking about it not like, well, I need to find out how many pounds of nitrogen my soil is going to mineralize in the course of the growing season, so I'm going to send my soils to California to figure that out. That's like, that kind of information, you're going to get back exactly on the surface what you think that might look like, right? It's not going to be very meaningful. But understanding what those values are, what that test reflects, and then what are you doing as a manager to help promote that or decrease that depending on whichever way you want that to go. So